everybody. Welcome. I hope you guys are having a good Monday morning. We are going to take a little bit to get this warm up done and let people come in and get settled. So let's take a look and get it done. Good morning. So we're using SOHCAHTOA right, finding sides. So we're moving on today. So we spent quite a time finding sides, and what we're going to do today is finding angles. And so pretty exciting stuff. Good morning, guys. Get going on this warm up. We're going to be working on angles today. Super exciting. People coming in. Good morning. We're just working on a little warm up. Come on in, work on this warm up. Good morning. Just working on a little warm up. Let's get started. This is a pretty good practice of what's going to be on the final two, guys. So make sure you guys can do this stuff. Yeah, good morning. People still coming in. Good morning. Do you mean the last day of school? Yeah, June 15th. Yeah, you're welcome. All right, guys, we're going to go ahead and go over this warm-up. So this is kind of summing up what we've done with finding sides, right? So today we're going to be moving on from finding sides. We're going to take a look at finding angles. Okay, so if you guys have questions, please let me know, because finding angles is going to be just enough different that it's going to be new. Okay, so taking a look at this, right? Okay, I first want to identify my sides. So opposite from the 90 degree, that's my hypotenuse. Furthest away from my angle is my opposite, and then adjacent is the one that's left over. So again, when you're solving multiple sides in one triangle, you almost want to forget about one of the sides, right? So if I'm solving for x, so I'm going to write down SOHCAHTOA, and I always like to write down SOHCAHTOA at least once so I can always look at it. So I'm looking, I have opposite and I want hypotenuse, so that's going to be sine. So to solve for x, I'm going to do sine of 27 degrees equals, the O comes first, so 15 over x, and there's my setup to solve for x. Okay, to solve for this, I'm going to want x off the bottom, so I'm going to multiply both sides by x, and I get x sine of 27 degrees equals 15. I don't want the sine of 27 there, so I'm going to divide both sides by sine of 27. So I get x equals 15 over sine of 27 degrees. Holy moly, I'm going to type this into my calculator. So I get 15 over sine of 27. You know what I just realized? I'm in radians, so I'm going to change back to degrees. And then I get x is approximately 33.04, like this. Okay. So again, if you guys have questions, please let me know. I'm going to be going through these relatively quickly because you guys had some time to work on it. So if you see something where you made a mistake or you have a question, just go ahead and ask. I'm also going to go ahead and solve for the y. So if I cover up the x, it has the opposite and adjacent. So I look at what has opposite and adjacent. TOA does, right? So I'm going to be using the tangent ratio. So I'm going to have tangent of 27 degrees equals, the opposite comes on top, so I'm going to have 15 over y. Okay, that's my setup. Then I'm going to solve this, right? I'm going to multiply by y. Okay, and then if you guys want a cool trick, oh, you know what? I just got called out. I did say to the nearest tenth, right? Sorry, I just spent a whole class with my algebra students. They're in the book. They're rounding to the nearest hundredth. You're right. So if we're rounding to the nearest tenth, it is definitely going to be 33.0. Thank you so much. I was just thinking about my last class where we were rounding to the hundredths place. I should get that tidied together. Sorry about that. So I am going to multiply both sides by y, right? So notice how I have both sides by y here. But I also see you can have some foresight and say, oh, hey, I'm gonna have y times this, so I'm gonna go ahead and divide by tangent of 27 at the same time, right? So I'm gonna get y equals 15 over tangent of 27 degrees. I'm gonna go ahead and type this into my calculator. So 15 over tangent of 27 degrees, and I get y is approximately, and I'm going to go to the tenths this time, so that's not 5 or higher, so I'm going to get 29.4. Okay, and there we go. So we got x and y. And again, if you guys have questions, please go ahead and ask, right? Because we will be moving on from this today. We're going to be doing angles. So just wrapping up our side stuff. All right, so I'm going to do the same stuff here. I might speed things up just a little bit. So I have my hypotenuse, I have my opposite, I have my adjacent. Okay, so we label these. And then if I want to solve for w first, w uses adjacent and hypotenuse. So adjacent hypotenuse is my cosine. So I would have cosine of 33 degrees equals w over 7. Okay, Notice how in cosine, the adjacent comes first on top. So I don't want the 7 on the bottom, so I'm going to multiply both sides by 7. And I get 7 cosine of 33 degrees equals W. This is my exact answer. When I go to type this in, I have 7 cosine of 33 degrees. I get that W is approximately, so if I go to the right one, see how that's 5 or higher, I'm going to come back and round the 8 up to a 9. Okay, so I get 5.9. Then, for my next one, for my Z, if I cover up my W, I have opposite and hypotenuse. So opposite and hypotenuse is sine. So sine of 33 degrees equals my opposite over my hypotenuse. Oops, yeah, Z over my hypotenuse. To solve this, I'm going to multiply by 7. I get 7 sine of 33 degrees equals Z. I grab my calculator. I go 7 sine of 33. And I get that Z is approximately, I go to the first decimal and look to the right. Is it 5 or higher? Nope. So 3.8. Okay. So I went through these rather quickly, right? Hopefully, if you guys aren't doing it quickly yet, we're approaching doing it quickly, right? Because in math, right, it's nice, always nice to get the right answer, but it's always better to get the right answer quickly so you can focus on other things in your life, like, you know, how many likes I have on Instagram. Okay? All right. So, anybody have questions before we move on? Like I said, we're going to be doing why can't I think of the word right now? We're going to be doing angles and talking about that today. Okay, so it doesn't look like anybody is writing any questions, so let's dive into the new stuff. Okay, so the new stuff is we're doing 9.6 and we're talking about inverse trig ratios. It should be inverse trig functions, I should say. I don't know why I wrote inverse trig ratios. Okay. So inverse trig functions. So to understand inverse trig functions, we have to understand what is an inverse. Okay, so what is an inverse? So the big thing about what an inverse is, think about your shoes. Now, we talked about this before. Oh my gosh, and of course, I don't have any shoes here. But the idea is you put on and take off your shoe every day, okay? So there is a put on action and a take off action. Those actions are inverse, as in they undo each other, okay? So you can think of putting on your shoe and taking off your shoe as inverse functions, right? One of the functions puts on the shoe. The other function, gosh, I don't like that this isn't square. There we go. The other one is, it's not. I'm just going to have to deal with it. Okay. The other issue, right, so is what does this mean mathematically, right? So we can think of it as something that undoes another thing. So an action that undoes another. Okay, so an action that undoes another action. So what are some examples in math? So let's take a look at some math examples. Oops, math doesn't have an E unless I'm spelling mathematics. Sorry, I was thinking mathematics. So math examples. So if I have x plus 2 equals 3, the opposite of plus is a minus 2. So that is like an inverse operation. Okay? Not a function, but an inverse operation. Okay? So another example of this would be like, so this is an example of a function. if I have x squared equals 49, what is the inverse of x squared? So this is where we're getting into functions, inverse functions. So the inverse of x squared is the square root. Okay, so they cancel out, so I get x equals plus or minus 7. Okay, so x squared and square root of x are inverses. Inverse functions. Okay, so does anybody have questions about that so far? So this is the example of an inverse that you guys have already seen, right? The square root undoes the square, or the square undoes the square root. They undo each other. Just kind of like if you put on your shoe, undoing that would be to take off your shoe. So an inverse function, right, undoes what is already there. Okay, now technically this isn't an inverse function. This is an inverse operation. Okay, we're talking about functions, things that you can graph. Okay, things that we can easily graph. Okay, so that's what an inverse is. It's an action that undoes another action. Okay. Well, the problem with what we have right now is that we have sine of an angle equals, right, a number opposite over hypotenuse. We have cosine of theta equals adjacent over hypotenuse, and we have tangent of theta equals opposite over adjacent. Okay, so the problem now is, right, all of these angles are hidden. So all of the angles are inside the function. That's our problem. All of the angles right now are inside the function. You can think of all of these angles as being a foot. All of these feet are inside shoes. You guys see how that works? So this angle is in a sine shoe. This angle is in a cosine shoe. This angle is in a tangent shoe. What we want to do today is we want to take off the shoe. We doing okay with that, guys? Does this make sense? Right? So the angle is inside the shoe, but we want the angle. We want to solve for the angle. Okay? So to solve for the angle, we need to take off. Now I'm going to put that in quotes because that's not actually a math term. We need, oops, did I spell we with 2 E's? Oh my gosh, I'm adding E's everywhere. To solve for the angle, we need to take off the function. Okay, so think of it as an angle inside of a shoe, and we want to take off that shoe. Okay, so to do this, we need inverses. Okay, so we have inverse trig functions. Undo trig functions. Okay, so I'm going to make a little table here. We're going to have the trig function, and we're going to have the inverse trig function. Okay, so we have inverse trig functions that undo trig functions. So we're going to have the trig function, and then we're going to have the inverse trig function. And just like squared and square root, it's just going to be a change in symbol. So for example, the trig function sine. The inverse trig function is sine, and then right next to it, a little -1. Now, it's not actually a -1. If you zoom in on this, it's actually this. Now, most books don't publish it like this. Like, it's almost, some books do like a backwards, but it looks like a -1. Now, if you guys remember from Algebra 1, anything to the -1 power meant that you flipped it. That's not what we're doing here. This isn't a -1. It is like a 1 with a little lower bar right here, okay? And what this means, this right here is inverse sine. Okay, so again, it's not a -1. It's like a 1 with a little bar on the floor. Okay, on the floor. Not in the middle, not up high, a bar on the floor. Okay, so inverse. So this is, we pronounce this as inverse sine. Okay, so then what about cosine? Okay, so we have cosine. Well, it's the same thing. It's cosine inverse. Okay, so again, we would say, right, or you could say inverse sine, or you can say sine inverse, or you can say inverse cosine, right? Or you can say cosine inverse. Doesn't matter. Either way is fine. Okay. And then we have tangent. And as you would guess, it's just tangent and then inverse tangent. Okay, so it might look like a -1, but it's not. The thing, it's on the bottom, right? And it's not a -1. It's not reciprocal. It doesn't mean it's flipped. That's something different. And we're not going to have time to learn about that this year. You're going to learn about that in Algebra 2, right? So that's going to be your cosecant and your secant and your cotangent. Okay, so these are just inverses. Okay, so that's what we're going to use today. Now, on a calculator, right? So if you guys are using a physical calculator, I want you guys to take a look here. So here's my sine, cosine, and tangent. Right above them, I have sine inverse, or inverse sine, inverse cosine, inverse tangent. Okay, so on a physical calculator, if you're using a physical calculator, they're usually the same button. It's just, you see how these are like green? That means I hit the green button first, and then I hit that button, and I get my inverse there. And you see how that looks like a -1? It's not a -1. So I just want to make sure you guys know that, okay? Not a -1, it means inverse. Okay? Now, if you're using Desmos, here I can show you guys really quickly what that looks like on Desmos calculator, because I know a lot of you guys are using Desmos. So give me just a second. Gonna bring that up here. So to get to Desmos, sorry, just a second, I'm going to make this bigger. Okay, can you guys see that okay? So sine, cosine, and tangent are here on Desmos, but you can't see sine inverse cosine. So you're going to go up to here, and you're going to go to function. And then boom, sine inverse, cosine, right? Inverse cosine, inverse tangent. They're all right here. Okay, so I can go like that. Okay, and then you can go back to main, and you can go to function. Okay, so does everyone sees that, right? So the inverses on Desmos, you have to click func, right, which is for function, and then they're right here. Okay, and then you know what's cool is that the sine and sine inverse are together, right? Boom, 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 boom. Yay! All right, cool. Anybody have questions about that? So again, Desmos calculator, pretty cool. All right. So So we're just taking the shoes off, guys. We're just taking the shoes off. So let's go ahead. Let's do a couple of examples of this, and then we'll do this. So have your calculator ready. So either have Desmos calculator open or have your physical calculator out. So let's do some examples of using inverse trig functions. Okay, so for this first one, we're gonna take a look at, we have tangent of A equals 0.75. So just write that down. So A is our angle. So we have tangent of A, and I just really want to write this down, right? This is our ratio. This is our angle. Okay. So we have tangent of an angle equals a ratio. So what we want to do is we want to solve for angle A. Now, just a quick quiz. What units are our angles in? Can you guys type that into chat? What units are our angles in? What unit are our angles in? What are the units of angles that we use? So like if I had an angle, it would be what units? There we go. Yeah, it's going to be degrees. So how do we know if we're finding a side or an angle? Angles must be in degrees, guys. They have to be in degrees. And if we were in person, I would be marking you down points for angles that don't have degrees, because that's not a degree angle then. Okay, so to solve this, what we're going to do is we need to get rid of tangent. So to get rid of tangent, you guys see how we have to, it's inside? We have to take off our shoe. Angle A is in a shoe. So we're going to take tangent inverse, right? Now we don't have to do this, but we can. I'm going to take tangent inverse of both sides, right? So I'm taking tangent inverse of the left and tangent inverse of the right. And what happens is those tangents go away, just like the square and square root go away. So what am I left with? I'm left with my angle A equals, and then this tangent stays. It doesn't cancel out. So I'm left with tangent inverse of 0.75. Okay. And that's it. That's the step. We took off the shoe. Do you guys see how we took off the shoe? I'm left with my foot, right? So now, if I type this into a calculator, I'm going to get the answer for this angle A. Okay, so let's try this out. So in my calculator, it's a green button. So I'm going to hit the green button first, and it says a little second, like I hit the second button, and then tangent inverse. And then I'm going to type in 0.75. I'm going to hit enter. And then let's keep going ahead and rounding to the nearest tenth. So if I go to this 10th here, it is an 8. If I go to the right, it is 5 or higher. So I'm going to round up to a 9. This would be 36.9. And if you left it like this, you would be incorrect because it's missing. This is an angle. It is 36.9 degrees. And that's how we know, are we talking about sides or are we talking about angles? So the answer here would be 36.9 degrees. Oops, and I should say approximately, right? Because we rounded like that, okay? All right, guys. Well, I'm going to have you guys try one on your own here, a couple on your own. Are we feeling okay with this? Is anybody having calculator issues? Anybody having calculator issues? All right. Let's take a look. So for this next one, I want you guys to solve for B. So I have sine of angle B equals 0.87. I want you guys to solve for B. In fact, while we're at it, let's do this. I'm going to do a third one. And we're going to do cosine of angle C equals 0.15. So can you guys solve for angle B and angle C? So again, this is mostly practice with, oh my gosh, an inverse, how do I use it? Where, how does it work? And how do I use my calculator? Here, I'm going to give you guys a couple of minutes to take a look at this. Okay, and if you guys have questions, now is a good time to ask questions, right? If you're having calculator issues or you don't know where to start, go ahead and ask me a question and I can help you guys out. Yeah. All right, guys. So, again, giving you an opportunity, right, just to play around with this. There's no context. It's just, hey, can we use it? What does it look like? Can we find it in our calculator? Do we feel comfortable? So I have sine of angle B equals a ratio, right? This is some ratio of sides, right? And I really want to emphasize that, right? The angle is here. The sides are over here, right? So when I do the sine, right, sine of B, I'm going to do sine inverse of both sides, right? Notice how I'm taking it of. So the sine's always going to be to the left of it, right? So sine inverse, that's going to get rid of the sine. I'm going to get angle B. The sine inverse stays over here, though. Sine inverse of 0.87. So I grab my calculator, and I say, okay, sine inverse of 0.87, and I get, now if I'm rounding this to the nearest tenth, I'm going to go to the first decimal. I'm going to look to the right. It is 5 or higher, so I'm going to round up. So I get B is approximately 60.5 degrees. Now check yourselves, guys. Did you put the degrees? If you didn't put the degrees, and I know this is frustrating, you didn't get it right. Okay, units are so important. Okay, so 60.5 degrees, and it might seem simple now, but when we start solving for angles and sides, it's going to be easy to forget, right? So we can't confuse what's an angle, what's a side. We know it's an angle because it's in degrees. Okay, here I'm going to do the same thing. I have cosine of C, right? And yes, that looks really good. Your answer is looking awesome. So I'm going to take cosine inverse. Cosines go away. I get angle C equals cosine inverse of 0.15. So I'm going to do that in my calculator. Cosine inverse of 0.15. And I get C is approximately, I'm going to go to the first decimal. I'm going to go to the right, and I'm going to say, hey, that's a 5 or higher, so I'm going to round up. I'm going to get 81.4 degrees. Okay, so again, it's a little bit new, right? It's a little bit different. And whenever we do something new and a little bit different, that opens us up to all sorts of mistakes to make. So make sure, guys, right, we're looking at this. We're undoing the shoe. We're getting the foot by itself. We're solving for the angle. Okay. Now, this, I hope you guys are thinking to the future. This opens up so many different possibilities, right? We now can find angles. And this is so important to a lot of things, right? With right triangles, right? We were like, okay, but like, how do you know it's 90? And, you know, like finding sides. Now we can find angles, and this is game changing, right? We can use this to, like, if we were on a boat or an airplane, we can use it for navigation, right? If we're building things, we can get precise measurements for angles and sides. Guys, this is pretty important. So let's go ahead. We're going to keep practicing and then take a look at what's next. Okay, so the next thing we're going to do, and this is what I mean, it's going to all come together, and this is where people make mistakes. We're going to do something that's called solving triangles. Okay, we're going to do something that's called solving triangles. And what this means is we're going to find all missing parts. Now, I agree with you guys. In real world, you probably, I mean, you're not always going to have to find all missing parts, right? Now, sometimes you will. But this is a good exercise. If you can find all the parts of a triangle, then you can find any part of a triangle. And that's what we're going for here. So solving triangles is good practice to finding any part of a triangle. And so let's do an example of this, and then I'll have you guys try one on your own. Okay. So let's do an example, and then we'll get going. And hey guys, this is going to take all sorts of different meanings. So for example, you can have all sorts of information and solve, right? But in this case, in this example, we're going to have a right triangle, and we're going to have this side is 3 and this side is 2, and then we're going to label things. So we're going to say this side, this is big A, big B, big C, and then this is also side So remember how opposite sides are connected? We're going to call this little c. And I know that's really hard, but it is the notation that mathematicians use. So I have big A, big B, big C, little c. So to solve this triangle, right? So to solve this triangle, we need, I keep adding e's to everything. We need to solve for the measure of angle A, the measure of angle B, and side C. Okay, so we need to find 3 things. We need to find our 2 missing angles, and we need to find our missing side. Now, there's lots of different, now this is what's really cool. There's lots of different ways we can approach this. You don't have to do one before the other. You have a lot of freedom on how you do this. So for example, did you guys notice how we have 2 missing sides? I mean, we have 2 given sides and we're missing a side. Now I could use trig to find C, couldn't I? Or since this is a right triangle, I can use Pythagorean theorem. So just for fun here, I could say 3 squared plus 2 squared equals c squared, because doesn't Pythagorean theorem still work? So for c, since I know 2 of the sides, I could go ahead and do this. Now I'm not always going to be able to do this, but in this case I can, so why not? So I'm going to do the inverse. See how I'm doing the inverse? Now I don't do plus or minus here because the minus doesn't make sense when I'm talking about a distance, right? But I can type this into a calculator. And I can go, oh, okay, the square root of 3 squared plus 2 squared equals the square root of 13. Okay, so I'm going to say this equals the square root of 13. Now, we could also do this doing trig, but especially those of you guys who don't have calculators that give exact answers, doing it this way is a really easy way of getting the exact answer, right? Yeah, so 3 squared, right? 3 squared is 9, 2 squared is 4, and then 9 plus 4 is 13. Okay. All right, and again, if you guys have questions, let me know. You could have used trig for this, but what's nice is I get an exact answer without needing a calculator that can give me an exact answer, right? 3 squared plus 2 squared is 13, square root of 13. So now we're going to go ahead and solve for A and B. What do you guys want to do? Well, let's do A. That seems logical. So there's part of my work, right? So now let's solve for A. So if I want to solve for A, well, angle A, right? So to solve for an angle, I need to know two sides, right? So for example, I can't do sine, that's 3 and C. Now I could, but remember, we never want to use an answer that we found. We never want to use an answer. So if I look at A, opposite of A is 3, and adjacent to A is 2. So if I write down SOHCAHTOA, SOHCAHTOA. So if I look at A, opposite of A is 3, and adjacent to A is 2. So opposite and adjacent. So I would say tangent of A equals 3 over 2. Now notice how to solve for the angles is the exact same setup as solving for sides. You pick a reference angle and you pick a ratio from SOHCAHTOA. Okay, it's the exact same setup. So again, right, we have our reference angle. The only difference here is now we know our sides, but we don't know our angle. So the new thing here is to solve this, I don't divide by tangent, right? It's not tangent times A, it's tangent of A. So I have to take the tangent inverse of both sides. So again, it's not tangent times A. I don't divide by tangent. I have to take the tangent inverse of both sides. So I get A equals tangent inverse of 3/2. So I'm going to go here and I'm going to take the tangent inverse of, right? And you can do fractions in calculators, which is really cool. So cool, man. Okay, and then what do I get? I get an ugly number. So I'm going to approximate it as 56 point, and then I see a 3, and then to the next is a 0. So I'm going to keep it at 56.3, and then I have to add degrees. So up here, I'm going to say 56.3 degrees. Now, I'm going to warn you guys, and if you have questions, please go ahead. The next thing we could do is we could say, hey, I know the angles add up to 360, right? See how that would be another shortcut? They have, I mean, not 360, that was silly. They add up to 180, right? So you could go 180 minus 90 minus 56.3 to get angle B. Now, the only thing I would caution you on that is that we rounded this answer, okay? So I'm just going to go ahead and show how to set up for B. So angle B is using, I want to use the two sides that are given. So in this case, opposite of B is 2, and adjacent of B is 3. Do you guys see how they switched? Opposite and adjacent switched depending on which one we're looking at. So for B, 2 is the farthest away, and 3 is close. So I'm still going to be using tangent. I'll have tangent of angle B equals my opposite side over my adjacent side. The B is inside a shoe. I have to take off the shoe. The tangents go away. I get angle B equals tangent inverse of 2/3. So let's see what that is. So it's going to be like the same thing, except I'm going to switch the 2 and the 3. So what do I get? I get B is approximately, and then here, so I am going to have to do some rounding because my first decimal is a 6, but the next one is a 9, so I'm going to round up to 7. So I'm going to have 33.7 degrees. Okay, so I'm going to have 33.7 degrees, like that. So these are my answers. And that is the process for solving a triangle. Now, solving a triangle, not each triangle we're going to solve is going to be the same. For example, this one had 2 sides, but we can also get one that has one angle and one side, right? But you're always going to have at least 2 things. You're always going to have at least 2 things. So just with that, does anybody have questions? Because in a second here, I'm going to have you guys try this on your own. You guys want to try this? Are you guys ready to try this on your own? Yeah. You guys are like, let's do this. Okay. We're going to try 2 different problems. Okay, so here's our first one. So I'm going to call this capital H, capital J, capital G. I'm going to call this 13. I'm going to call this little g. Little g sounds like a rapper. I'm going to call this 25 degrees. Sorry. When I talk a lot, my voice dries up. And then I have H down here. So I want you to solve the triangle, right? And that means you're going to find all of the missing pieces. And I'm going to give you guys 3 minutes to do this. Okay, so we're finding all of the missing pieces. So that's angle G, side G, and side H. All right, let's take a look at this, guys. If you have questions, please go ahead and ask. I don't know if we'll have time, but for me to help you. But if you want, you can come to my office hours and you can get help there. I just don't think we're gonna have extra time today. So we have to find. You have to find some extra things here. So I'm just gonna go ahead and point out that we know this is 25, this is 90, and this we don't know, but we do know they're going to add up to 180, right? So that is that angle H plus angle J plus angle G are going to add up to 180 degrees. And since angle H is 25 degrees and angle J is 90 degrees, right, we can find angle G. So to solve this, right, I'm going to subtract 25 and 90 from both sides. 90. So I'm going to take 180 degrees minus 25 minus 90, and I get angle G is 65 degrees. Okay, so there's one of my answers, right? So just really quickly, right, if you can see a shortcut, go for the shortcut. Now, if you're like, oh, I didn't use that shortcut, I used Trig. Great, go ahead and use Trig. Okay, but this is much faster. So if you ever find shortcuts, I encourage you guys to use the shortcuts as long as they're mathematically sound. So next I'm going to solve for G. So I'm going to act like H isn't there. So G is adjacent, and then this is hypotenuse. So if I write down SOHCAHTOA, what uses adjacent and hypotenuse? That is going to be cosine. So I have cosine of 25 degrees equals the adjacent, right, goes first, so G over 13. Okay, and so I'm going to multiply by 13 on both sides, and I get 13 cosine of 25 degrees equals little g. And I'm going to type that into a calculator. So make sure, right, we don't want cosine inverse. We just want cosine of 25 degrees, right? And I get little g is approximately 11 point, and then 7 is my first one. I look to the right, it's 5 or higher, so I'm going to round up to 11.8. It's a side, so no degrees. So I'm just going to say little g is 11.8. Okay, so again with my angle, I had a degree. Here I'm rounding to the first decimal place. Okay, then I want to find h. So if I cover up g, h is the furthest away, and I know my hypotenuse, so I have opposite and hypotenuse. Opposite and hypotenuse is sine, so I have sine of 25 degrees equals h over 13. I want to, sorry, I'll get rid of this clock there, kind of in the way. So I'm going to go and multiply by 13 on both sides. I get 13 sine of 25 degrees equals h. Let's type that into our mighty stallion here. 13 sine of 25, and I get h is approximately 5 point. If I round to the first decimal, I get a 4, but the second decimal is 5 or higher, so it's going to be 5.5. So I'm going to get little h is 5.5. So with that said, we are at the end of class. Does anybody have any super quick questions? Then go ahead and ask. If not, then I will see you guys tomorrow, and we will practice doing more of this solving for angle bits. Bye, guys.